Hello everybody, welcome to MNR-ACADEMY. Now in today's video, I'm going to teach you the most important CBQ, competency based questions related to most important chapter in class 10 science, chemistry, chapter 4, carbon and its compounds. So actually this is the most important for our upcoming board exams also. So most of the questions may have interlinking with this chapter and the previous chapters also. So let us see how this CBQ has been asked in this, which is released by Cbse recently. How tough it is and how to answer them. What they are expecting exactly from us. So chapter 4, carbons compounds. Once again, welcome to MNR-ACADEMY. If you like this video, if you need more support in CBQs, please subscribe MNR-ACADEMY and share our videos to your friends so that they also will be benefited. Now, let us start with the first question. The first question in this, they are saying that on undergoing complete combustion in an adequate supply of oxygen, an organic compound, so any kind of organic compound, produces carbon dioxide and water vapor as the products. So that is what, as we all know, any kind of combustion reaction releases carbon dioxide and water. Now they are asking, based on this information, which of these following homologous series could be compound belong to their asking. So means the given PQR, which will shows this under this, like they are of course organic compounds, produces carbon dioxide and water, means undergoes combustion reaction. So first of all, let us comes to the alkanes. So alkanes, hydrocarbons. So whatever it is, alkanes or alkenes or alkynes, everything undergoes. They are a good combustible nature. They are actually the fuels. So we can say they'll undergoes combustion reaction and they'll produce the carbon dioxide and water vapor. Coming to the alcohols, alcohols also you might be studied. They are also a good flammable substances which will undergo a combustion reaction, and as well as aldehydes. So you might be have studied aldehydes. So you have taken the aldehydes. So the functional group present in the aldehydes, if you verify it, it is CHO. That is what the functional group. So C, the single bond H and double bond O, aldehydes. So they are also good fuels. Of course, they are the hybrids of alkanes or hydrocarbons. So they are also good consumption, like combustible in nature. So we can say aldehydes also undergo combustion. So let us verify with one example either they are producing carbon dioxide and water or not. For example, if we take alkanes, the smallest alkane which we all know, first one is methane. So methane undergoes combustion reaction which will produce as carbon dioxide plus water. So first one is okay. Second one, alcohol. So the most any kind of alcohol you take, the familiar alcohol for us is, you can take methanol or ethanol. Let us go with methanol. CH3OH. So if you have taken CH3OH, so if it is react with the oxygen, it will produce as again carbon dioxide plus water. So the same way, let us take aldehydes. So in example, so first one, CH3 methanol ethanol. Let me take CH3CHO methanol plus O2. So sorry, 5O2. So it will produce as also carbon dioxide plus water. So from this I can say all the given substances undergoes combustion reaction. So anything, any PQR is our right answer. Now, one more additional information I'm giving. In aldehydes, the first aldehyde called as formaldehyde alone is not combustible in nature. formula is CH2O, which is the IUPAC name is methanol. So methanol is the one which will not undergo combustion. So other than this, all the aldehydes we can get the like they will show the combustion reaction. So that is what you have to remember. So the first question answer is NEPQR. Next, second one, a compound with which of the following functional groups is most likely to cause the decomposition of baking soda to produce carbon dioxide? So, if you notice this question, baking soda to produce the carbon dioxide, which will be happening actually at the second chapter, you might be studied the properties of baking soda or uses of baking soda. So baking soda is treated with the edible organic acid. Baking soda treated with the edible organic acid called as tartaric acid. If you check it in NCERT, page number 31, uses of baking soda will be having that. Baking soda plus tartaric acid, edible tartaric acid, or else we can add citric acid, whatever it is. So that is what, this is the when they are asking, which is the functional group is most likely to cause this decomposition reaction. So they are the acids, organic acids, or we will say this is what carboxylic acids. So example, tartaric acid, citric acid, acetic acid, whatever it is. So what is the functional group present in this? COOH means C double bond O, single bond OH. So that is the functional group present in all the kind of carboxylic acids, or we will say organic acids. So what is the correct answer for this? C double bond OH. Yes is the correct answer. So fourth option. See, this is question is from fourth chapter, carbon compounds, but it is linked to chapter 2. So that is the importance. That is what the carbon compounds always will be having a connection with any chapter. Next, question number 3. 1 mole of ethene and 1 mole of ethane are separately made to completely undergo addition reaction. So first of all, you might be remember addition reaction in chapter 4 when we are studying the properties, chemical properties you might be getting. There you can see. So as we are chemical properties of carbon compounds when we are studying, so this is what addition reaction will come. So they are saying in addition reaction, if you will see, by adding the hydrogen under the presence of catalyst called as nickel, we will convert the unsaturated compounds, unsaturated to saturated. So that is what even example vanaspati ghee, preparation of vanaspati ghee, hydrogenation of oils, you might be studying. Under the presence of nickel, hydrogen gas, by passing the hydrogen gas. The same thing they are asking here. 1 mole of ethene and 1 mole of ethane. So ethene formula as we all know C2H4. Ethane formula is C2H2. So both are unsaturated only. So by passing the under the catalyst nickel, by passing the hydrogen gas, we will convert them into saturated compound. Now, so they are asking which of the following will be different for these two reactions they are asking. So let us write the reactions for ethene and as well as ethane. Two saturated one means ethane. So first if you take ethene, C2H4, you can see in the NCERT addition reaction if you want. That is the most important one. Page number 71. If you check it, addition reaction, vanaspati ghee, formation of vanaspati ghee, that is what hydrogenation of vegetable oils using nickel as a catalyst So we will say the example of this addition reaction. You might be studied even so many examples. So all ethene now. So ethene by reacting with hydrogen gas under the presence of nickel, it will converting into ethane means C2H6. Now ethane, same way, let us check for ethine. Ethine is C2H2. So C2H2 if you have taken again, it will pass the hydrogen gas under the presence of catalyst nickel. It will also produce C2H6. Ethine. Sorry, ethane. So now if you have noticed it, but to get the ethane, we need 2 moles of hydrogen gas here. So that is why balancing here 2H2 will come. So you check it here, only 1 mole of hydrogen gas, here 2 moles of hydrogen gas to form the ethane. So now which are the different they are asking? The number of moles of the saturated compounds formed. So you check it products. 1 mole of ethane, and here also 1 mole of ethane. So it is not different. Same for both. Now second one if you will verify the number of moles of the hydrogen consumed. So here 1 mole of hydrogen consumed, if you check it, and here only 1 mole it is consuming, here it is consuming 2 moles. So that is only different. So what is the answer? P is not different, but Q alone is different. So only option 2 is the right answer. So this much in detail explanation is needed. That is why we must have a complete idea of this entire equations. Next, the same next question also in the same page, NCERT page number 71, addition reaction. Just below this addition reaction, you'll be having information regarding which oils is good for us and which oils is bad for us. So as we all knows, animal fat or animal oil from the animal fat, and as well as vegetable oil. So if you have taken vegetable oil which contains unsaturated and animal fat contains saturated. So if you have taken for our body unsaturated fats only, oils only, fatty acids only helpful for us. So related to that paragraph only, this question, if you have checked, vegetable oils are healthier than animal fat. True. Reason, they contains a long unsaturated carbon chains, but animals they contain saturated carbon chains. So these saturated carbon chains are not good for our body. That is why we must consume vegetable oils which are healthier than animal fats. So both the reason is also true and assertion is also true. The reason is true because of assertion is true because of reason. That is why reason is explaining the assertion correctly. So we can say both A and R are true, and R is the correct explanation of A. That is what answer. So page number 71, if you will verify, you will find it. Next question. Alkanes are saturated compounds of carbon and hydrogen and can be represented by a general formula CnH2n plus 2, where N is the number of carbon atoms. Now, an example of such compound you take ethane. So this is the ethane. Now, they are asking, let us see, that is the information given. Now let us comes to here. Maya has a compound of carbon and hydrogen whose formula is C3H4. So if you have seen this formula, observe very carefully. It is not a alkanes, but the given information they are saying alkanes, but this is not a alkane, because if you have taken the given information alkane, C3H8 should come. So it is not a alkane. So C3H6, if it will come, it is alkene. So it is not even alkane. So it is alkyne. That is what we people can identify as it is, but it is having 3, C equals to 3. So as you know, metheth pro. So it is a propyne. Name of this compound is propyne. So it is the alkyne family. So now if you have noticed it, all of you, what is true about the type of flame this compound will give on combustion? So this is the introduction itself. Will study types of alkanes, alkenes, and alkynes. Remember, alkanes are good fuels, or we will say zero emission fuels, or less smoke and as well as pollution will causes. They are the good fuels which will produce us like less smoke and as well as carbon dioxide. But if you have taken alkenes and alkynes, they are unsaturated hydrocarbons. So by burning, they will burn with a sooty flame or smoke flame. So that is what you have to remember. Alkanes will burn with a non-sooty flame, but alkenes and alkynes they will burn with a sooty or smoky flame. So that is what sooty or smoky flame. That is what you have to remember. Now they are asking what is the draw all the possible straight chain structures of this compound. So as we know, same chemical formula but different structures. That is what we will say isomers. So that isomers may be alkenes or alkynes. So both we can draw because it may contains the double bond or it may contains the triple bond. So that is what both together we will say unsaturated hydrocarbon. So they're asking only straight chain. Of course, branched chain also we can say branched chain and as well as closed unsaturated hydrocarbon also cyclic also. But they're asking only straight chain. So for this one, you might be noticed for C3H4. So first of all, let us draw only two things will possible straight chain. So all three carbons are in straight chain. Here also three carbons are in straight chain and four hydrogens are there. So let me put the two hydrogens here and here and here also. Then you can see middle carbon they will get the double bond. So this is the one of the straight chain hydrocarbon for C3H4. Name of this one is propylene. Next, same way, here I have taken a carbon one triple bond and one single bond H, and here if you notice last carbon will get three hydrogens. So name of this one is only we know propyne. C triple bond C single bond, understand, C. So which will get totally two straight chain structures of this compound. This is how it will be happening. So hope everybody understand this. So this is what it will be regarding alkenes. But see the given data alkenes they are giving, but asking alkynes. Remember, alkanes are good fuels having high calorific value and they will burn like less smoky. But if you take alkenes and alkynes, they're more smoky fuels. That is what you have to remember. They will burn with the sooty flame or smoky flame. That is okay. Next, bromine water. So again, this bromine water is also related to addition reaction only. Addition reaction, again page number 71 in NCERT. Okay, but you can see in addition reaction only we will add hydrogen. With the hydrogen only we are converting. Unsaturated to saturated. But instead of unsaturated to saturated, we also instead of hydrogen, we also undergo this addition reaction addition reaction with chlorine and bromine also. So that is what we will do. Instead of H2 chlorine, we can do with the Cl2 and Br2 also. So that is one of the only, this is what bromine water. So if you have taken this addition reaction with the unsaturated compounds, like only, remember, addition reaction is only for unsaturated compounds to converting into saturated. So the bromine is used to form a bromine water here. So addition of bromine is particularly important, very, very important, because it is used as a test for unsaturated compounds, means both alkenes and alkynes. So it's a test to alkynes, both we can use to find with the help of this bromine. So that is why it's most important one. So bromine water is a reddish solution of bromine when shaken with an unsaturated hydrocarbon. Maybe it is alkenes or alkynes. The red color of the bromine water disappears because the bromine is used up in an addition reaction. So that is a basic thing. Basically, bromine will react with the uh, unsaturated hydrocarbons, means alkenes and alkynes. That is, you have to remember it. Now, Kohli has three test tubes. So remember, both alkenes and alkynes we can find with the bromine, but we cannot distinguish which is what, because both are colorless. We cannot identify. Now, Kohli has three test tubes containing hexene, and hexane. So if I have taken three test tubes totally, a boy is having a three test tube. So we don't know what is present in what test tube. All are colorless substances. So it has been noticed that, let me take this test tube is A, this test tube is B, and this test tube is C. Now if I have noticed A, I want to identify what they are asking. Which of the three compounds can be identified using the bromine water test? Give a reason for your choice. So as we all know, the three test tubes, what we don't know. But in these two test tubes, surely one is hexene and another one is hexane, and the another one is hexane. So these two we no need to identify. You check it because both will react with the bromine water, and the red color of the bromine water disappears. So in this ABC, any two, they will convert the red color will disappear, and because that is what bromine water, because bromine water will react with unsaturated hydrocarbons. So ABC, whatever it is, suppose for example B and C I have found red color is disappear. So I will say this both are unsaturated hydrocarbon. Okay, but I cannot identify which is hexene and hexane. But I can identify one perfectly. That is what hexane. That is alkane, because alkanes cannot convert. Okay, they cannot decolorize bromine water. Hexene and hexane, they can decolorize. That is what decolorize the bromine water, but alkanes cannot. So I will identify which of three compounds can be identified. Which of the three compounds can be identified using the bromine water test? Hexane I can identify, because alkanes never shows decolorize with the bromine water. Now, what is the reason? That is what the reason. So they do not decolorize bromine water. Alkanes you can write, or we can say hexane do not decolorize decolorize bromine water. So that is the reason I can identify hexane first. And remember, this the bromine test is only the most important test we will use to identify butter and as well as vegetable oil, because Vegetable oil contains unsaturated fat so that it will disappear the color. But if I have taken cooking oil or vegetable oil, whatever it is, please remember butter animal fat, so which contains the saturated one, so which will never shows any reaction. Hope everybody understand. So that is what cooking oil decolorize the bromine water, or will take vegetable oil, okay, or cooking oil. So they will be shows the decolorization reaction, but butter cannot. So that is why we will use this test, bromine water tool test to distinguish chemically between a cooking oil and butter by using this or vegetable oil. So that is what it is. This is also under addition reaction only it is. Next. Next one, a carbon compound of molecular formula C5H10O containing a ketone. So ketone means you all knows minimum number, the N is equals to starts from 3 only, because the if you want to form the ketone, minimum number of carbon, the carbon C double bond O must contains always in between two carbons, so that it will be N is equals to 3 first. Now what they are asking, they are giving us some ketone C5H10O. So now they are asking, draw the structure of three isomers of this compound having a ketone group. So this is what are the simplest question. So we can make every time position of the oxygen changing, and we can solve this one easily. So first let us take three isomers. First isomer is all carbons are in straight chain. So 3 plus 2 5. So the second carbon I will keep the double bond. So it will come CH3, first one. Second one is CH2, and third one also CH2, and last one again CH3. So that is the first compound name, first isomer of this compound. So the name of this one is pentane, pentane 2,1, that is the name. Second one, put this double bond to the third carbon, that's all it is. So it will come CH3, CH2, C double bond O, C double bond O, single bond CH2, CH3. So that is the second one. So the name of this one, see that for the third carbon, you can see 1, 2, 3. And this one before 1, 2. Lowest possible number should come. So the name of this one is pentane 3,1. That is the thing. Now the last one is the parental chain must contain 4 carbons. That is the third isomer. If you'll form, you'll get it. You might be all having a practice already. So third one is CH3, CH3. And here one branch also there. That is what methyl group and double bond O. So if you have taken the name, so as well carbon double bond is coming to the second carbon and branch is coming to the third one. So first we'll start with the branch. IUPAC name 3 methyl, functional group is methyl. So 3 methyl. Next you can take parental chain number of carbons. If you have verified parental chain 1, 2, 3, and 4. Only 4 are there in parental chain, so that it will come butane, and second carbon is having the ketone functional group, so that it will come but 2,1. That is the third isomer of this one. So all of you should learn how to draw the structure of the isomers of these functional groups. So it's very, very important. So butan 2,1. So that is the 3 isomers of C5H10O. Pentanol is isomers. It's very, very important. Minimum for every functional group, you must learn the isomers N is equals to at least 6 or 7. So n is equals to 1 to n is equals to 7. You must learn the isomers by practicing your own. Next one, ethanol. So as we all know, the formula of ethanol is C2H5OH. Is heated with the alkaline potassium permanganate to give a compound X. So this is one of the most important reaction. In page number 71 again, the reaction is oxidation reaction. So oxidation reaction, you can see under the presence of alkaline KMnO4 plus heat, or you can take acidified potassium permanganate K2Cr2O7, we are going to get the compound X, that is what? Ethanoic acid, CH3COOH. That is what the reaction which is there in NCERT page number 71. Now, C2H5OH alkaline KMnO4 and under the R K2Cr2 it will give you CH3COOH. Now they are asking how many carbon atoms will compound X contains. You can check it 1 and 2. So 1, 2. So we will say 2 carbon atoms. Next, compound X. X means what? This ethanoic acid CH3COOH now will react with the ethanol in the presence of an acid catalyst to give a compound Y. So that is what if you have taken CH3COOH acetic acid, CH3COOH, ethanoic acid or acetic acid will react with the ethanol, means acid plus alcohol will give you a compound Y under the presence of acid. That acid is also H2SO4 because here H2SO4 will work as a catalyst. So this reaction is only, you might be seeing, a formation of esters. That is what we will say is that. So if acid will react with the alcohol, which will form the compound Y, which we used to call as formation of esters. So that is only we'll get the compound called CH3COO C2H5. That is a compound. Along with that, we'll get the byproduct also, which is known as water. So, but of course, they are asking about only Y. So this is what CH3COO C2H5. So if we'll check it in NCERT page number 73, it will be clearly mentioned action of ethanoic acid. That is what we can write it. So everybody, you can do it. CH3COO COOH plus C2H5OH will react. They will form CH3COO C2H5. So that is what under concentration sulfuric acid H2SO4 it will be forming. So now name the type of compound formed in the above reaction with respect to the functional group it contains. So what is the functional group contains in that? This compound ester. Ester is the functional group which is present in that. So that is what name the type of compound they are asking. So the name of this compound name, the functional group is ester. If you want, the name of this one is ethyl acetate. So that is the name of that one. Or we can say ethyl ethanoate. Ethyl ethanoate. That is what it is. And the functional group is ester. Ester is present in them. Next, state one characteristic property of compounds of the type of compound Y. So this is very familiar thing for us. They'll be having the same page number 73 in NCERT. You can check it. Below the equation, it will be having sweet smelling substances. So that is what we all know. Sweet smelling is indicating formation of esters. Next, state one use of compounds on this type. The same paragraph we can find this as it is a sweet smelling substance. These are used in making perfumes and they're asking only one, you can write two, and flavoring agents. So this is what this question. So hope you all clear with this. So anybody is having anything doubt, you can ask. So that is what it is. Next, question number 9. So compounds with identical molecular formula but different structures are called structural isomers, or we will say isomers. So you might be already studied till n is equals to 10 at least isomers. So n is equals to 1, n is equals to 2, n is equals to 3. So number of isomers are 1 only. Up to n is equals to 3. Now n is equals to 4 if I have taken, then the number of isomers are 2. If n is equals to 5, number of isomers are 3. If n is equals to 6, n is equals to 7. Like up to 10 you can do. And up to n is equals to 7 is most important. If you want to find the number of isomers, you can use the formula 2 into n minus 4 plus 1. So this formula will give you number of isomers up to n is equals to 7, less than or equals to 7. Now in the case of saturated hydrocarbons, what is the minimum number of carbon atoms needed in a molecule? Saturated means alkanes. So alkanes, so if I have taken, have to a structural isomers, means more than one isomer is possible. If you notice it here, n is equals to 1, 1, n equals to 1, 1, 2 equals to 1, 3 equals to 1, 4 equals to 2. So if you want to see needed a molecule for it to have a structural isomer minimum, then it must be n is equals to 4. That is what it is. Equal. Next, draw the structural isomers of the saturated hydrocarbon having the minimum number of carbon atoms mentioned in A. So A, how much we mentioned? N is equals to 4. Now, if you substitute N is equals to 4, let us find how many isomers. Basically, you might be knows N is equals to 4 means isomers are 2. If you want, you can substitute in this formula. So 2 power 4 minus 4 plus 1, which is equals to 2 power 0 plus 1, which is equals to 1 plus 1, which is equals to how many? 2 isomers we can form. So let us form the 2 isomers of this one. So either it will be coming or not, we'll verify. So we all, I think you are all very familiar already. So one is straight chain. So all it is n is equals to 4. So butane it is. So C4H10. So all straight chain. So you can draw. It will be like CH3, CH2, CH3, CH2. Next CH2 and CH3. So there is the first one. The name of this one is N-butane. Okay. Next the second one is three are in parental chain. C single bond C and middle bond again a branched chain. So that CH3CH, CH3CH3. So that is what it is. The name of this one is, so as it is second carbon is having the branch, so that 2-methyl and parental chain, you check it, number of carbons are 3, so that it will come. 3 means prop, so it is a propane. So 2-methyl propane, parental chain number of carbons are 3, so propane, 4 butane. So that is what. So this is only we will say isomers of butane having n is equals to 4. So that is what it is asking. Next, a open chain. Next question is the most important one. Very, very typical question. So you have to listen very carefully. Now, an open chain hydrocarbon X having the general formula CnH2n minus 2 is hydrogenated in the presence of catalyst. So again the same thing. CnH2n minus 2 means this is a general formula for alkynes. So we are all familiar already, we are learning it. So alkanes CnH2n plus 2, alkenes CnH2n, alkynes CnH2n minus 2. Now they are asking, state the number of moles of hydrogen required to completely saturate 1 mole of compound X. So this is not a new. Already in previous one of the question we solved. If you want to convert, once again I'm saying, all alkenes, two alkanes under the presence of nickel. Again the same thing. NCERT page number 71 addition reaction. So if you want to take alkenes into alkanes, we need 1 mole of hydrogen. Same way, if you have taken alkynes into alkanes, you need to take how much, everybody? Yes, please. Two moles of hydrogen. That is what you have to remember it. Alkynes, 2 moles of hydrogen is required to make it into alkanes. This is what we solved in a previous also. So you might be check it here. Uh, Yes. So you can see converting alkenes into alkanes, 1 mole of hydrogen, alkynes into alkanes, 2 moles of hydrogen. So that is what it is will comes. So if you have taken, so it will be how many moles it is they're asking? 2 moles we need. So that is what it is converting completely. That is if it is alkenes, 1 mole. It is alkynes, that is what 2 moles it is. Next, B part is the most typical part which you have to understand very carefully. So as we know, alkynes will start from only n is equals to 2. That you have to remember. So no methane will be present. No methane. Only it will start from ethine and next one propine and next butane. So that is you have to remember. Now, what they are saying, the X substance, of course, whatever the alkynes, we need two moles of hydrogen to convert into alkanes. Now they are saying this X compound, we don't know which alkyne. It may be a ethane or propine or butane or pentane or hexane or heptane. We don't know. But they are saying that which contains a carbon-carbon single bond. Okay, means if you notice it, ethine and propine does not contains single bond, carbon-carbon single bond. They may contains, of course, isomers. They may contains double bond or triple bond. So if I have taken ethine, as we know, which will be having only triple bond, C triple bond, C, H and H, because the formula is C2H2. So it is not the X, I can identify. Next, second one, propine, C3H4. So C3H4 already we have drawn in the same questions. Two structures you might be noticed. This is what propadiene and as well as propine. So two structures, two straight chain we have drawn. In this one, if you notice it, single bond may occurs in propine, but if you take the another one, propadiene, that double bonds are forming, but there is no single bond. Single bond carbon. So it is also not. So that is why this is little confusing question. So X is not a ethine or X is not a propine, because you can see they are saying hydrocarbon X contains carbon-carbon single bonds. Okay, apart from the single bonds, state the number and the type of other carbon-carbon bonds that could be possibly present in the compound X. So the compound X is C4H6. So this is the compound which will be having like along with the single bond, which will be also having the other thing, double bond as well as triple bond. So this is only called as butane. So first, if you have taken structure C triple bond C, single bond C, single bond. So if you have taken hydrogens, so totally 6 hydrogens. So this is name is only called as 1-butane. So triple bonds are number of triple bonds 1. Next, another structure if you have drawn C double bond C, single bond C, double bond C. So first here C, then 2 hydrogens, here 1 hydrogen, here 1 hydrogen. Next here last one two hydrogens. Okay, so the name of this one is, if you have noticed, so carbons are present at 1, 2, and 3. So 3 carbon, 1 and 3. So 1, comma 3, butadiene. So which will contains two double bonds. Here one double bond and here one double bond. So answer is two CC double bonds and one CC triple bond along with the single bond. So that is the answer. So answer here also they have given the same thing. So the X is butane. That is what we have to think little carefully and we have to answer it. So hope everybody will understand this. So that is butane. So that is the things will come. So this is what question number 10. Next, question number 11. Show below are the structural formulae of four carbon compounds. So, two of these compounds are most likely to have the similar chemical properties. So, identify these two compounds, give a reason for your answer. So, if you notice it, so having the most similar chemical properties. Similar chemical properties means definitely they are homologous. Homologous means there may be hydrocarbons or maybe hydrates of hydrocarbons like any functional groups. If they are having the same functional group, they are actually as same chemical properties as they are isomers. So if you have noticed it here, first one the functional group present is ketone. Second one, C single bond O H. You can notice. So what is the functional group present in this C single bond O H? So actually it is C double bond O aldehyde group. So but actually single bond only it is. So okay, OH, sorry, it is OH functional group. So OH functional group means alcohol. That is what. So this is a ketone and here it is alcohol. Next, here again C double bond O single bond OH. So it is not C double bond O ketone. C double bond O single bond OH. So it is carboxylic acid. Next, last one COH. So again it is alcohol. So if you have noticed similar chemical properties having same functional group. So Q and S is the answers. So Q and S are the similar chemical properties because both are having the same functional group. So identify of these compounds are most likely to have similar chemical properties, that is Q and S, because they're having a functional group is alcohol, which is OH. Q and S. Now, identify which of these compounds are likely to have the same boiling point. Justify your answer. So you might be remember molecular mass increases, then melting and boiling points also having a changes in any substance. So if you need in NCERT, all of you, if you can read 67th page, second paragraph, uh, paragraph number 2, if you'll understand, they're saying that as the molecular mass increases in any homologous series, whatever it is, of course, you can take this is a ketone, this is the carboxylic. Definitely, they don't have any kind of common boiling point or melting point. Maybe you might be thinking this alcohol, this is alcohol, and this is alcohol. Maybe having the same functional groups, maybe having a same boiling point. No, definitely, this will be having different molecular mass. Class 9 you studied molecular mass, and this is also definitely having different molecular mass because this form, if you'll take this one, the formula is CH3OH, and this one is formula is CH, totally now 1 2 3 3 carbons, so C3 hydrogens 3, 4, 7 and 8, C3H8 O. So definitely molecular mass is different. So molecular mass is different. They're saying a molecular mass increases in any homologous series. Gradation in physical properties as seen. That is what melting and boiling points increases with increasing molecular mass. So they definitely do not have same. So that is what you have to be very careful. So then you can say the answer for this one is none of them. That is what you have to remember. The most important question it is. Okay. So what is the answer for this question? None of them will get it. None of them. None of them will be having the same answer. So based upon the molecular mass you have to say. So please read this paragraph. Such an important paragraph. Definitely you might be not touch the paragraph till. So that is what. Next. Heating an alcohol with concentrated sulfuric acid results in the dehydration of the alcohol to give the alkene as shown by the reaction of ethanol to give ethene. So this is dehydration reaction. Chemical properties of ethanol, you will get this one, CH3 CH2OH, concentrated sulfuric acid. Actually this is the dehydrating agent to remove water from the ethanol, excess water from the ethanol dehydrating agent, so it will produce CH2 double bond CH2. Means, as we know, which will produce, it is alkenes, double bonds. So that is what it is, reaction of ethanol to give ethene, means alkene. So now, Pramila heated 2-butanol with concentrated sulfuric acid. Means instead of ethanol, butanol she has taken. So nothing different. Butanol only she has been taken instead of ethanol. So now they are asking, write the structural formula of all the possible products of this reaction. Okay. So if you have checked NCERT, if you want this reaction, you have checked NCERT page number 72, will be having dehydration, reaction of ethanol. Second one, reaction of like reaction to give unsaturated hydrocarbon. That is what it is. Yeah, alkenes, ethene is forming. So now Pramila heated tube butanol shown below with concentrated sulfuric acid. Same exactly. Now, if you have taken products, you can put hot concentrated sulfuric acid. Okay, so which will produces the compounds. So you can see the it will produces majorly, basically the major product is 2 butene will produce, that is what, CH3 CH double bond CH3. Now along with that they are asking, write the structural formula of all the possible products. Only it will be 2 products will possible, that is what butene, that is sure, but the position of the double bond will be varies. So one is butene, this is the major product, basically we'll get the major product is this one product, but all the possible products they are asking. So we'll get to 2 products. One is this one. Second one is 1-butene. So the formula is CH3 CH2 single bond CH double bond CH2. This is 1-butene and this is called as 2-butene. So these are the 2 products which will obtain by heating the 2-butanol. So we will get anything by heating the 2-butanol. The same thing we will get it. So hope everybody will understand this. So that is the most important one. So which will help you to solve in exam more better. So these are the 2 products, CH3 CH double bond CH CH3, 2-butane and 1-butane. That's all. So this 1-butane double bond is here. So carbon 1 here, 2-butane 1 and 2, second carbon it is having. That is what it is. So two only will form. Write the structural formula of all the possible products, 2 products, 2-butane and 1-butane. Clear. Next, 13th question. Ethyl propanate is a colorless compound. Ethyl propanate is a colorless compound with a pineapple-like smell. Okay, it is present naturally in some fruits such as kiwi and as well as strawberries. Kiwi and as well as strawberries. So now, if you have taken here, the structural formula of ethyl propanate is given below. This is what the structural property of ethyl propanate. Ethyl propanate means you might be understand in page number NCERT page 73. If you have checked it, you will be get it. That name is only called as, you can see CH3, CH2, COO, CH2, CH2, CH3. CH3, COO, you might be written, exactly the book is wrong. CH3O it is actually. So CH3, CH2, like ester it is. So CH3, COO, C2H5, that is what ethyl acetate. But here we are having ethyl propanate. So you can see ethyl acetate, CH3, COO, C2H5. But here you can see CH3, CH2COO, C2H5. So this is ethyl acetate and this is ethyl propanate. So both are what? Esters only. That is what you have to understand. Ester is the functional group which is fruity smells, or that is what it is getting. So now, if you have noticed it very carefully, propanate, ethyl propanate, but we know ethyl acetate only. But there, see that how it is tricky these questions. Ethyl propanate. So this is what will happen. Now they're asking, write the names of the carboxylic acid and the alcohol from which this compound is formed. So unless you are having a complete idea, we people cannot answer this question. So if you'll see, as we know that this one CH3COO, C2H5, ethyl acetate is formed by ethanoic acid plus ethanol. Now it is formed by propanate. So ethyl propanate it is. So it is formed by two substances, propanoic acid and as well as, if you have taken propanoic acid and as well as ethanol or ethyl alcohol, that is the two substances present in this. That is what you have to remember it. So you can write it. The compounds which are present, names of that one is propanoic acid. Propanoic acid, CH3, CH2, propanoic acid. So what is the common name of this one is propionic acid. So you might be studied already. Formula is CH3 CH2COOH, or we will say C2H5COOH. So this is what propanoic acid. But ethyl is there, so that this is the acid. We will say CH3CH2COOH, and acid is, now you can see acid or alcohol. Acid is over alcohol. So alcohol is ethanol. Ethanol or ethyl alcohol, both are same. Ethyl alcohol. So as we all knows that formula C2H5OH, ethanol. So C2H5OH, if you have got, we'll get this product. Okay, along with that we'll get water also. Now apart from mixing the carboxylic acid and the alcohol, carboxylic acid is propanoic acid and alcohol is ethanol or ethyl alcohol, what should be done to form this compound? So as we know, in that reaction page number 73 in NCERT, we need a catalyst also. So that catalyst only we know, concentrated sulfuric acid. So that is what we have been done it. So hope everybody will understand. So we need to add a catalyst called as a presence of catalyst. Ethanol presence of a catalyst called as acid. That acid is only used to called, okay, sulfuric acid. That is what H2SO4 will say that. Okay, this reaction is only, we can say, saponification reaction. You might be heard it. That is the most important one. Saponification reaction. Okay, so because this is only used to preparation of soaps, that is why we can say soaps are called as sodium and potassium salts of long chain carboxylic acids. That is what we have to remember. So it's very simple question, but we have to we need to know very clearly. Unless you know the clarity, we people cannot answer this one. So that is what it is. Next, an alkane has 11 carbon atoms arranged within ring structures as shown below. So if you have noticed, what is the molecular mass or molecular formula of these alkanes? So each one, each carbon should satisfy 4 bonds. So like that, if I'll keep on keeping two hydrogens, you can verify here 2 hydrogens. Now, but this carbon already 1, 2, 3 over, 3 bonds over. So one more hydrogen will come. And here this carbon also 3 over. So one more hydrogen. Remaining we will get 2, 2. So now if you count it, so we will get the formula. First count the number of hydrogens. Sorry, carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So C11. Now count hydrogens 2, 4, 6, 8, 9, 10, 12, 14, 16, 18, 20. So C11, H20. That's all. C11, H20 is the answer. Next. Manasi wrote the names of 4 compounds as the first members of their respective homologous series. Now, first one, methanol, of course. Next, methanol, and this is methanol. Next one is methanol. Next one is methanoic acid. Now they are asking, which name has she written incorrectly? Justify your answer. Now, observe very carefully here. If you are very familiar with the functional groups, of course you can see alcohol we can write with the methanol, ethanol, propanol and all. Next, that is what OL will come. Next, aldehydes also we can write with AL, methanol. That is methanol. This is methanol, propanol, butanol, like that. But if you have taken one, ONU1 is the ketone family. So if you have noticed the ketone family, the minimum number of carbons is 3 because C double bond O, the functional group must come between the 2 carbons. So methanol is not possible because the one which will start from there, ketone, is a propanol only because C equals to 3. So that is why if you take methanol is not possible, only possible with the propanol. So no methanol is existed. So that is what we people can understand. So that no methanoic as well as methanoic acid, we know that acid, carboxylic acids. So it will start from methanoic acid, ethanoic acid, propanoic acid, everything will form. So that methanol is not possible because the ketone family first itself starts from propanol. So that is why no methanol. So we can say answer is same thing. So methanol is not possible. It will start with the propanol. So that is what it is the answer. So hope everybody will clear with that, will understand it. So you have to remember always a ketone family will start from a A ketone must contain at least 3 carbon atoms in its molecule. That is what you have to remember. Minimum 3 carbons. That is what it is. So this is. So what name should she has written instead of? So it will start from propanol. So instead of methanol, she need to write propanol. That is what you have to remember. Next. Organic compounds belong to different homologous series can be isomers. For example, propanol and propanone are isomers. Can an alkane and an alcohol be isomers? Why or why not? That is what it is asking. So if you notice it, propanol and propanaldehyde, CH3CO CH3. If you have taken propanol, if you have taken, so for example, what is the formula will come propanol CH3 CH2 CH3 CH2 CHO. This is what propanol. So I can write as a C3H6O. This is what propanol. Now, if you have taken, or we can say propanaldehyde. This name is propanaldehyde, as it is aldehyde group is there. Al aldehyde group. Same way propanone. Propanone, if you have taken, the formula of propanone is CH3COCH3 because it's a ketone family. So we can say finally C3H6O. So this is a ketone family, this is aldehyde family. So both are having the same chemical formula. So they will be isomers. We can say that. Can alkane and an alcohol be isomers? Why or why not? No. So if you have noticed, alkane, they will never be possible because alkanes are hydrocarbons. So if you notice, alkanes contains only hydrogen and carbon. That is what carbon and hydrogen alone is present. That is what we will say alkanes. But alcohols, along with the hydrogen and carbon, will be having also oxygen also. So they will never be isomers. So that is what you have to remember. So they cannot be isomers because only carbon and hydrogen alkanes, but oxygen also present. So not possible at all. That is what you have to remember. Next, question number 17. Homemade vinegar is produced from the wine. The wine is taken in a clean glass jar and shaken well to aerate it. Some water is added to the jar and it is kept undisturbed in a dark place at room temperature, undergo fermentation reaction. Now, after 3-4 weeks, the vinegar would be ready to use. Now, name the functional group of the main organic compound present in wine and as well as vinegar. So now vinegar is, you are all very familiar. Vinegar, the thing is present is a carboxylic group. So we all people knows that. Carboxyl group, or we will say carboxylic acid, which is COOH. Now if you have taken wine is what? Alcohol. So alcohol is what? Wine actually, it is a hydroxyl, or we will say it is alcohol. So alcohol is only called as OH. Hydroxyl we used to say one. So that is what we have to remember it. So hydroxyl or vinegar. So hydroxyl OH, vinegar COOH, carboxylic acid. So that is what hope you all understand and you can make it. Now you can see if you open in page number 73, you will be having this one. So that orange color box, alcohol as a fuel, fermentation process, how we are getting it. Now based on the atoms getting added or removed, when wine is converted to vinegar, name the type of reaction that happens. Actually, it will come under oxidation reaction. So that is what we can say. It is oxidation reaction. If you open page number 73 in NCERT, page number 73 in NCERT, you will be having an orange color table, alcohol as a fuel. So there you'll get a clear idea of that one. So now, if you have noticed this one, under this oxidation reaction it will come, so that we are using this one. Now name any chemical reaction that would be used for the same reaction if it is carried out under our out in the laboratory, they are asking. So if you have noticed it very carefully, when we are carried out this reaction basically under the lab, then we will use a substances, same thing like oxidation reaction. We need a nascent oxygen, like a nascent oxygen to produce it. So that is why a wine into vinegar, vinegar means acetic acid. So if you have taken this, basically that it is produced from molasses or sugar. So sugar contains what is actually glucose. We can say that glucose, sugarcane juice, which is a dark brown liquid which we used to call as molasses, which is left behind it. Okay, as in the sugar industries, that is what we are using for production of vinegar. So now this reaction will come under oxidation. That is what you might be studied in our school. Chemical properties of ethanol. First one is combustion reaction. Second one is oxidation. So this oxidation only will produce oxidation controlled combustion. We will say it is a controlled combustion because we are not allowing to providing complete O2. We are providing O here, nascent oxygen. We can say it is a controlled combustion. That is what we people can remember. So if this is taking place in a laboratory, we will carry it out under this reaction, like for example CH3CH2OH, that is what ethanoic acid, sorry, ethanol or ethyl alcohol. So if it is under O2, that is O2 ille O, nascent oxygen. It is nascent oxygen, means freshly released oxygen from oxidizing agent. So here we are using the oxidizing agent, that is what an aqueous solution of potassium permanganate containing sodium hydroxide, that is what we will say alkaline potassium permanganate solution. So we will use it as a here there will be like production of alkaline, that is what alkaline KMNO4 KMNO4 or acidified K2Cr2O7. So under this we'll use, these will produce actually oxygen, nascent oxygen, and the reaction will take place. They will produce CH3COOH plus water. So the CH3COOH only acetic acid, vinegar, we will say, or ethanoic acid. So this is what the reaction. So what is the reagents that would be used for the same reaction? If it is carried out in lab, we'll say potassium permanganate or potassium dichromate. That is what acidified potassium permanganate, sorry, the alkaline potassium permanganate, or we'll use acidified potassium dichromate. They are the oxidizing agents. That is what you have to remember. So this nascent oxygen come from oxidizing agents only. So that is what it is. So hope everybody will understand this. This is one of the most important one which you need to learn it. Next, 18th one. Polythene is a plastic made from ethene, CH2CH2. When ethene is subjected to high pressure and moderately high temperatures, ethene molecules react with each other to form a large molecules of hundreds of times bigger, forming the plastic. This property of carbon atoms is instrumental in the formation of polythene. So as we know, that is what we will say self-linking, okay, or linking, or we'll say catenation. So that is one of the most important versatile property of carbon. So which you have noticed it, in NCERT book you might be studied versatile nature of versatile nature of carbon. One of the properties, this NCERT page number 62, if you have verified, you might be finding that versatile nature, catenation property, self-linking. So first point number 1, you can check it, you'll be finding that. So that is what the answer. The ability of carbon atoms to link with each other to form long chains. So that is only we will say catenation. So that is what they are asking. Next, study the following information given and answer the questions that follow. Now, ethanol is a renewable biofuel because it is made from biomass. Ethanol is a clear biomass means it is molasses in the sugar industry. Ethanol, ethanol is a clear colorless alcohol made from a variety of biomass materials. So whatever it is, biomass, like ethanol producers mostly use food grains and crops with the high starch and sugar content, such as corn, sorghum, like alcohol. That is what we can say, alcohols. Sorghum, barley, sugar cane, and sugar beets. The most common ethanol production process today use yeast to ferment the starch and sugars to corn and sugar cane and sugar beets. Now, what is the chemical formula of ethanol? So, as we are very familiar, so it is CH3CH2OH. That's all is ethanol. Next, what other compound is obtained as by byproduct when ethanol is obtained from a sugar? Ethanol is obtained from a sugar. So if you have noticed, that is what molasses, sugar industries, as I told you. So byproducts, if you write the reaction, so C12H22O11 plus H2O. That is what we will say like a maltose. So it will produce us C6H12O6. That is what glucose. Now this one again will undergoes that is what fermentation. So C6H12O6 glucose only, which will produce C2H5OH plus it will produce carbon dioxide. So that is what the reaction it is. So it is there in page number again, the same thing, molasses production of that one. You can check it, page number 73 in NCERT, you'll be having that. But equation is not there, so you can learn it. So along with that, it will, like we can see, a fermentation of alcohol it will produce. So we can see it will produce as a carbon dioxide also. It will decompose and will produce ethanol. Ethanol plus carbon dioxide will produce. You must learn that. So answer for that one is what would be the product formed when ethanol undergoes a byproduct is obtained from a sugar. So byproduct is carbon dioxide. Next, if the what would be the products formed when ethanol undergoes complete? As when ethanol means alcohol. Alcohol undergo complete combustion. First question you might be remember, it will produce carbon dioxide plus water. That's all it is. So C2H5OH undergoes combustion. So what will happen? You must be remember first combustion properties. So which will be reacting with oxygen. That is what combustion, which will produce carbon dioxide plus water plus you can see heat plus light also it will produce. So that is what chemical properties of that one. So you can water vapor plus heat plus light. So that is what it is. Complete combustion. Next, last question. What would be the products formed when the ethanol undergoes complete combustion? Support your answer with a balanced chemical equation. So this is what the balanced chemical equation. 2CO2 plus 3H2O plus heat plus light also will come. So if you are not writing a chemical equation, mark is not allotted. That is also you have to remember. So this is what the entire carbonates compound chapter, which will like competency based questions. Some questions are very difficult and some questions are very easy. So hope you all understand this questions very clearly. So if you like this video, please subscribe my channel and share with all your friends. Thank you everyone, and I'll come out with the next video with another chapter. That is what metals and non-metals. Thank you all.